Right, we're ready for section 8.2 on solving compound inequalities. So these inequalities is kind of like two inequalities, but they're put together with some kind of connective. Um, we'll see the word and we'll also see the word or in some cases. And so we'll talk about how to deal with both of those words and what they mean mathematically. To begin with, though, what we're going to do really is solve the two inequalities separately as we would have before. So in between this and, we have an inequality here and an inequality there. I'm going to solve them both separately to begin with, and then we'll talk about what to do with the and. So we want to get the x by itself, so I'm going to subtract the 1 from both sides here, and we get negative 2x is less than or equal to 6. Alright? Divide both sides by negative 2, right? When we divide by a negative, don't forget we flip the inequality sign. We get x is greater than or equal to negative 3. Alright, so that's one inequality. Now we have this other one here, right? I'm going to subtract the 7. We get 2x is greater than or equal to 11 minus 7 is 4, right? Divide by 2. Do we have to flip the inequality sign? Good, you all said no, right? Okay, that's what I thought. Because we don't divide by a negative here, we divide by a positive. And so divide by 2, inequality sign stays the same, and we have x is greater than or equal to 2. And we have this little and in between, right? So this is kind of a solution, but now how do we put this in interval notation, right? And how do we graph it? Those are a couple of tricky points here, right? So here's what I like to do. I like to actually graph it first. Sometimes, but most of the time I'll graph it first. So let's see. I'm going to make a number line. What I like to do is graph the first one, the first inequality, kind of above, and graph the second one below. And with and, we're going to see where the overlap is. So and is means where do they intersect. In fact, a mathematical term is often used to replace the word and is intersection. So if it does this and this, where does it do both, right? Where does it intersect? So this inequality, so I put a negative 3 somewhere, right? And I'll put a 2 somewhere. So we want to know where x is greater than or equal to negative 3. I'm going to graph this little piece above. So x is greater than or equal to negative 3. That happens. I have a bracket, right? And it goes this way. And x is greater than or equal to 2. Well, we'd have a bracket. I'm going to do this one below. And we'll go this way. And the question is, where do those intersect? So if we were to bring those together to the middle of the line, where would they overlap? And we can visualize that hopefully in our head. If we brought this one up and that one down, they would overlap only on this piece here, right? So they would overlap only here. I'll use my highlighter here. Okay? So the solution to the graph is not this part, or this part really, but it's this part right here. So you might do this on paper first, and then on MyLab, you put the final solution on MyLab, okay, when you do your homework assignments. And so, yeah, this part really goes away because we don't really need it. We're looking for the intersection. Now, what we would do in interval notation, I'll show you, okay? So, and I could have done that first. Maybe I should have. I don't know. So the interval notation for this guy, I'm going to write this out to the side. Interval notation, we'd have everything greater than or equal to negative 3, right? So we would have a negative 3 comma infinity. We have an equal to bar, so there's a bracket with the negative 3, parenthesis always with infinity. And is replaced with the intersection symbol. So in mathematics, the intersection symbol is an upside down U. Looks like that. And that symbol will be available to you in the little tool pad on MyLab. And then this guy is x is greater than or equal to 2. So same kind of thing, but this time we have 2 to infinity. Equal 2 bar, so we need the bracket. Okay? So this would be your interval notation that you would write. This would be the graph. Although this looks big and nasty, what happens is it gets condensed in the graph because we have to only look at where we're intersecting, which means this stuff here really goes away. Okay. Alright, let's look at another example. We're going to solve each separately again. I'm going to subtract 2. I get 3x is less than 9. Divide by 3, x is less than 3, right? Okay. This one, I'm going to subtract the 2. I get negative 3x is less than or equal to 12. Here we divide by negative 3. Maybe I'll show that. When we divide by a negative, don't forget, we flip the inequality sign, right? So x is greater than or equal to negative 4. And we have an and in between. Maybe I'll go ahead and do the interval notation here. Okay? Interval notation, x is less than 3. That would be everything from negative infinity to 3, right? We use a parenthesis because there's no equal to bar. And we replace with the intersection symbol. Okay? And this is x is greater than or equal to negative 4. So that's everything from negative 4 to infinity. And I use a bracket because we do have an equal to bar and the 4 is included. So this would be your interval notation. I'll put a box around that. That's my answer, right? And then we got to look at the graph. Okay, so again, the graph, make a number line here. I have a 3 somewhere and a negative 4. Let's put negative 4 here, and maybe 3 over here. So we go from everything from negative infinity to 3, right? So that would look like this. Negative infinity to 3, right? I'll do that above. And negative 4 to infinity would look like this. We have a bracket, and we go all the way to the right. And what we're going to do is look at where those two would overlap. So if I imagine this top graph coming down and the bottom graph coming up, where do they intersect? Well, they would overlap exactly from negative 4 to 3. Okay? And then we could shade in the middle. And that's what our graph would look like. Okay. Again, and is intersection. We're looking at what the two sets have in common. I like to graph one above and one below and look at where they come together. Now the above and below part, when you give your final answer, we don't need those anymore, so that you would do on paper. But what you would put in MyLab is just this guy right here. So you're going to do some work before you start entering that graph on MyLab. Alright, so let's do one more with and then we'll move on to or. This one, let's see, we have 5a is greater than 0, right? So we divide by 5, we get a is greater than 0. 5a plus 4 is less than or equal to 9. I subtract the 4. I get 5a is less than or equal to 5. And divide by 5, I get a is less than or equal to 1. I didn't have to flip any signs here because I never divided by a negative in either case. Alright, so this is, and we have this and in here, right? So we get a is greater than 0 and a is less than or equal to 1. Okay, so let's do the interval notation. A is greater than 0. That means we go everything from 0 to infinity. The parenthesis because we don't have equal to bar. We have parenthesis with a 0. We always have parenthesis with infinity. And we replace with an intersection symbol. And then a is less than or equal to 1. That means we go everything from 1 to infinity, right? Or no, negative infinity to 1. So negative infinity to 1. If a is less than or equal to 1, 1 would be the largest value in that set. That would be your right number we have here. So this is our interval notation. That's part of our answer. The graph is the other part. So I'm going to do as I've done before. I'm going to graph part of it above and part of it below. Okay. So if I graph part of it above, a is greater than 0, I'll put a 0 somewhere and a 1 somewhere. Right. 1 is bigger than 0, so it needs to go to the right. But so a is greater than 0. That would look like this. A is less than or equal to 1. That would look like a bracket and going this way. And again, we want to look at where it overlaps, right? So if we bring those two together, they're going to overlap right here. And I'll use my little highlighter. Alright, we shade everything in the middle. So that's what our graph looks like. The top and bottom part, again, we don't need anymore. We've combined them into our solution set. Alright, so that's examples with using and now we're going to look at or. Or in some cases I think is easier because you don't have to look at intersections. Or is the symbol we use in math is the union symbol. We just put the two things together. Or in math is an inclusive or, which is one or the other or both. So we got to look at any number that fits either of the inequalities basically. So let's solve both sides just like we did before. We subtract 3, we get q is greater than 4, right? Here we subtract 1, we get q is less than or equal to negative 4. Alright, and we have this word or. Okay? So let's write the interval notation. Q is greater than 4. That means everything bigger than 4. So at 4 comma infinity. And I use parentheses because there's no equal to bar with a 4, right? Or we're going to use the union symbol, okay? Which is a regular U basically. And that symbol will be available to you in the MyLab toolpad. And then we also have Q is less than or equal to negative 4, so we would have everything from negative infinity to negative 4. And we have a bracket with the negative 4, right? Alright, everything greater than 4, everything less than or equal to negative 4. Now, if we graph these on a number line, I'm still going to do the top and the bottom thing, but it's not as necessary with the or, and I'll show you why. So we have a negative 4 smaller than 4, so it goes on the left somewhere. 4 is over here then somewhere. So everything from 4 to infinity would look like this. Everything from negative 4 or negative infinity to negative 4 would look, I'll do this one below, would look like this. But or is not the same as and. We're not looking for an intersection. In fact, if this were an and, there would be no intersection and you would have no solutions, right? And that happens sometimes, so be aware of that. If this were an and, we would have no solutions at all, right? It'd be the empty set. But it's an or. An or means we combine the two together, so anything we have graphed gets put on the number line. So this would be our solution again in interval notation. The graphing solution, we just combine the two graphs, so I'm going to put this piece on here and this piece on here and then do the shading. And alright, so that's our graph. We have two disjoint pieces together that form the graph. Maybe I'll highlight that. I like to do that. Highlighting is fun. Alright, so this graph, again, we don't need this piece here anymore, this piece, because we put them on our number line, and that graph would be our answer. Alright, we have two more ors to look at. We have 3 is greater than 4m plus 2. Again, I like my variables on the left, which makes this one a little tricky, but maybe I'll do something else, which I could show you. Since the variable's already on the right, I'm going to leave it on the right this time for now. So I'm going to subtract 2 from both sides. And then I get 1 is greater than 4m. Then I'm going to divide by 4, right? Divide by 4, and I get 1/4 is greater than m. Now, if I don't like the variable on the right, and it's on the right, I can just flip everything, right? Read right to left. M is less than 1/4, and I'll write that down. That way I have my variable on the left, and it will make more sense to me when I'm trying to graph things, I think. This one, the variable is on the left, so that's good, but I'm going to add 3. I get 4m is greater than or equal to 1. And I'm going to divide by 4 again, or multiply by 1/4, which might actually be better in this case, but I'll go ahead and divide by 4. So I get m is greater than or equal to 1/4. Okay, so we have this inequality or that inequality, right? Translating this to interval notation, m is less than 1/4 would be everything from negative infinity to 1/4. We have a parenthesis, right? Parenthesis because there's no equal to bar. Or translates to the union symbol in mathematics. Union means you're putting these two things together. And again means intersection, you're looking at the overlap. But alright, so m is greater than or equal to 1/4. That's everything from 1/4 with a bracket to infinity. Bracket because we have an equal to bar, 1/4 is included. Alright, so on a number line, what's this look like? This first inequality, so we need a 1/4 somewhere, right? This first inequality, it's everything from negative infinity to 1/4. That would look like this. The second one is a bracket with the 1/4, everything from 1/4 to infinity. So unlike the and, the or, again, we combine both of those. If we imagine those both coming up to the line and combining them, it would form the entire number line, right? So if we graph this, we include the entire number line, everything. In fact, all real numbers are solutions to this compound inequality because the whole real number line is shaded. Okay. So again, we have our two parts here. We have our interval notation, which is part of our answer, and we have our number line, which in this case is entirely shaded, which is the other part of our answer. All right, one more or problem to look at. We subtract 4. We get 2z is greater than or equal to 4. Divide by 2, we get z is greater than or equal to 2. Here we add 3, we get 4z is less than 4. Divide by 4, we get z is less than 1. Okay? And we have our or. Translating this to interval notation, z is greater than or equal to 2. That would be everything from 2 with a bracket to infinity. Or gets translated to the union symbol. And then z is less than 1. That's everything from negative infinity to 1. With a parenthesis, right? Because we don't have the equal to bar. Now let's graph it. Okay, and this is part of my answer. We go to graph it. Number line, let's see. This first part, we need a 1 and a 2. 1 is smaller, so it's on the left. 2 somewhere. 2 to infinity would look like this. Negative infinity to 1 would look like this. Again, with or, we combine them both. Both of those sets come to the number line. So we have this, and we have this. And we're going to shade appropriately, right? Oh, sometimes I like to shade these guys too. Alright, so both of those sets get put on the number line, and that is our answer. Just make sure you keep straight the difference between and or. And, like the problems we did at the top, the first 3, we only looked at the intersection of the two sets. It is possible you might not have any intersection and then you would have the empty set for an answer. Or you're going to include both sets on the number line. Sometimes they overlap completely and fill the entire number line like we have here. So those are some things to look out for, and that's it for section 8.2.